Alright, we're going to do number 18. Number 18 says determine whether wxyz is a parallelogram using distance and or the slope formulas. We're going to use the distance formula here. Distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so the way we're going to do this is we're just going to go in order: wx, xy, yz, zw. Alright, so we're going to be finding the distance between wx first. Then we're going to be finding the distance between, we can do right here, xy. Then we can find the distance between yz. Then we're going to find the distance between zw. Okay, so that means we have w is at 0, 8. We have x, which is at 610. Then we have x is at 610. Then we have y is at -1, -1. Then we have yz, we have at -1, -1. And this is for y. And then we have z, which is at -7, -3. Then we have zw. Z is at -7, -3. Then we have w, which is at 0, 8. Then I'm going to organize these. Now that I have this information, I'm just going to move this up so we can see it a little better. I'm going to organize it using subscripts. So this will be my x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. I'm going to use the distance formula here, which is up here. I'm going to use all of it for all of them. So first we need to check d is equal to the square root of 6 minus 0 squared plus 10 minus 8 squared, which we get is equal to 6 squared plus 2 squared, which is equal to the square root of 36 plus 4, so we get the square root of 40 for our first one. So we're just going to keep it in square root just to make it as easy as possible. Then from here, we're going to do the same thing here. D is equal to the square root of, we have -1, -1 minus 6 squared plus -1 minus 10 squared, which is equal to the square root of -7 squared plus -11 squared, which is equal to, we get -7 times -7 is 49 plus 121, get square root 170. Okay, that's our second answer. Let's do it again. So what we have here is d is equal to the square root of -7 plus 1 squared plus -3 plus 1 squared, which is equal to 6 squared negative plus -2 squared, which is equal to square root 40. Only reason why I was able to do it so quick is -6 squared and -2 squared will be the same as this one up here. Okay, so these are the same. So we have two equal sides so far. Now I have to see if xy is going to be the same as zw. If these are different, this will not be a parallelogram. If they are the same, we're good to go. So here we have d is equal to the square root of 0 plus 7 squared plus 8 plus 3 squared, which is equal to the square root of 7 squared. 8 plus 3 is 11, so plus 11 squared, which is equal to 49 plus 121, which is 170, square rooted. So this is the same, this is the same. So since we have the following, we have square root of 40, square root of 40, then we have square root 170, square root 170. We indeed have a parallelogram. When we have a parallelogram, we have two congruent sides. So the opposite sides are congruent. So we do have a parallelogram. So yes, a parallelogram. Yes, W, X, Y, Z is a parallelogram.